Up to this point, we have successfully set up and configured a basic network that will support our containerized applications, ensuring it meets the criteria of security, high availability, and performance. Configuring everything manually through the AWS console has been a lengthy process. This method becomes particularly cumbersome and error-prone when dealing with multiple accounts. To streamline this process, automation is the key. CloudFormation is a tool provided by AWS that enables infrastructure provisioning using a declarative language such as JSON or YAML. We will explore CloudFormation script that replicates all the configurations we have implemented thus far. While CloudFormation marks a significant advancement, the process of learning, creating, and maintaining these scripts can be quite laborious. The cloud paradigm promotes the infrastructure as code, so infrastructure should be programmable using common coding languages. This is where AWS Cloud Development Kit or CDK comes into play. With AWS CDK, we can use programming languages like TypeScript, Python, Java, Go, and .NET to write our infrastructure code. This approach integrates the software development lifecycle, including writing unit tests and functional tests to validate your infrastructure logic. Taking it a step further are CloudKitect components, which offer an even more sophisticated approach. For example, the CloudKitect component VPC allows developers to construct the entire infrastructure we have learned and built so far with just a single line of code. This level of abstraction simplifies the infrastructure building process significantly, making it more accessible and efficient. If we were to write a CloudFormation script to provision this infrastructure, this is what it would look like. As we can see, this template comprises of approximately 1300 lines of CloudFormation code, which will be a nightmare to maintain. Now let's see how easy it is to provision the same infrastructure using CloudKitect component VPC. We just write one line of code and deploy our infrastructure. Behind the scenes, it will create all the resources we have learned so far to configure our VPC. And within 5 minutes or so, our network infrastructure will be ready to use. Let's take a look at the console to verify what got created. As we can see, it will create 3 public subnets, 3 private subnets, and 3 isolated subnets. It will create a routing table for each one of them, and looking at the resource map, we will see that public subnet is connected to the internet gateway, whereas each of the private subnet is connected to its own NAT gateway for high availability. It has also created VPC flow logs and appropriate roles and policies to send the logs to CloudWatch log group. That's the power of CloudKitect. See you in the next video.